Hello everyone. Welcome to the NPTEL tutorial session on analog communications EE135 course. Today is week 8 of problem solving session and today we will be focusing on random processes. So please follow along the lectures 38 to 43 of analog communication. Sorry. Hello everyone. Today is the week 8 of problem solving session of NPTEL Analog Communication. So today's topic is random processes and this corresponds to the lectures 38 to 43 in the NPTEL Analog Communication course. So please follow lectures 38 to 43 before attending this online session as the problems will be based on the topics that have been covered in lectures 38 to 43. So as I said, today's topic is random processes and there will be 10 questions which we will be solving along together to help you understand various topics covered under the random processes. So with this, I will begin. Question number 1. Question number 1 is that a strict sense stationarity process is necessarily a wide sense stationary process. So a strict sense stationary process is necessarily a wide sense stationary process. So a triple S process is necessarily a WSS process. Is this true or is this false? So the correct answer is that it is true because strict sense stationarity is as in the definition it is strict. So it has a very specific and specific regulations under which a random process will qualify as a strict sense stationary. Whereas in wide sense stationarity, the conditions for stationarity are relaxed. So the strict sense stationarity will be covered inside the wide sense stationarity. So for the answer for option 1, question 1 is A, true, because triple S process are a subset of WSS process. Triple S process, strict sense stationary process are a subset of WSS process. So the correct answer is A, true. Okay. Question 2. If Y and Z are independent, then which of the following is true? If Y and Z are independent random variables, which of the following are true? So there are three statements. Three statements. Y and Z may or may not be correlated. They are uncorrelated and they are correlated. Surely. So you have three statements that if they are independent, are they correlated, are they uncorrelated, or are they may or may not be correlated? And since these three cover the whole spectrum of correlation, so none of these is not a viable answer here. So the correct answer will be that since they are independent, they may not be. So first is may or may not be correlated. Let's leave it. So are they uncorrelated or are they correlated? So if Y and Z are independent, so Ex E of F F or P P F. Hmm. So E of xy is equal to Ex into Ey. Okay. So here the thing is that if they're independent, y and z are independent, then so as I said previously that independence means if x and y are independent, ex y is equal to ex into ey. Now correlation coefficient rho is equal to exy. It is defined as exy minus ex into ey. So as you can see, by definition, this is 0 for independent x and y. That is that. So it is uncorrelation. Independence implies uncorrelation. So B. 2 is B. The autocorrelation function of a message signal is this. So what is the value of E x square 10 x square t? So x square t means what is a okay, so to do this, let's go to the question again. The autocorrelation function of a message signal is this Rx tau. Find the value of E 10 x square t. So let's first write the definition. Rx tau is equal to xt plus tau dt. Rxx 0 is equal to minus infinity to infinity xt into xt, so x square t dt. So this is E of x square t. So E of 10 x square t will just be 10 times this. And Rx at 0 in this graph is given to be 50. Rx at 0 is 50. So 10 times 50 is equal to 500. Done. So option D, 500. Check whether the following statement is true or false. The following function is a valid autocorrelation function of a WSS process. Xt equal to Rx tau rectangular t of tau. So the autocorrelation is a rectangular function. So does the what is the power spectral density? So check the validity of the power spectral density. So autocorrelation is given to be autocorrelation Rx tau is given to be rect t by tau. So Rx tau so PSD is PSD is Fourier transform of this Rx x tau. So Fourier transform of rect t by tau, which is sinc tau t. Sinc tau t. So this exists. So PSD exists. So therefore, okay. So yeah, sinc tau t exists, but PSD equal to sinc tau t can be negative, is not strictly positive. So power spectral density is the amount of unit power that is present in each frequency unit. So it is the amount of power that is present in each frequency unit. So power per unit frequency. So in essence, this power spectral density is having the same dimensions as power. So it should always be positive because power can never be negative. But so PSD should always be strictly positive, but PSD is not strictly positive. PSD should always be strictly positive, but sinc tau t is not strictly positive. It can be negative, right? It's like this. The function goes like this. So it has regions where it is negative. This region, this region, this region, this region. So these are all negative regions. So here, therefore, sinc tau t sinc tau t is not a valid PSD, is not a valid PSD. Therefore, T is a valid is not a valid autocorrelation function. So the answer will be false. Answer B, false. So let's go to question number 5. The two-level semi-random binary process is defined as st equal to a or st equal to minus a, where n minus 1 capital T to small t nt. So t small t is between n minus 1 capital T and nt. So it is either a or minus a. So it is a binary process, and the levels b and minus b occur with equal probability. So uh, the wave being positive and wave being negative have the same probability. T is a positive constant and n belongs to integers. So, what is the autocorrelation of two signals, one at 0.5 t and one at 0.6 t? This is the question. Please try to solve this question. I will give you 5 minutes to try this question on your own. Then I will solve it. So I'm back, and let's start with the solution. So between n minus 1t and nt, so between two integer values of time periods, the binary process is a or minus a with equal probability. So because t1 is at 0.5t and t2 is at 0.6t, they are both at between n minus 1t, that is 2 minus 1t and then 2t. So question number, this is I think 5, yes. So the time period is n minus 1, the time period has to be n minus 1 between n minus 1t to nt. Now RYY 0.5t, 0.6t. Here 0.5t is all between 2 minus 1t, that is 1t, and 2t. Rather it is between 1 and 0. So 1 minus 1 and 1 into t. Similarly here it is between 0 and 0.6t is between 0 and 1t. 0.5 t, I'm sorry, this is 0.5 capital T, 0.6 capital T. So both of them can be A or can be minus A with equal probability. So they can be A square, means A into plus A into plus A. So plus A into plus A with a probability of half into half, 1/4. They can be plus A into minus A. But since this is autocorrelation, so we will be only concerned with the mod values. A square by 4, 4 times. So all of them will yield a square by 4. So ultimately this will be a square. So the correct answer is C, a square. Question number 6. A random process consists of three sample functions, yts1 equal to 2, yts2 is equal to 2t, and yts3 is equal to 3t squared, each occurring with equal probability. So there is three samples in the sample space. So one is 2, one is 2t, and one is 2t squared, 3t squared. So the PDF is either 2, so they are all with equal probability. Thus, the probability distribution changes with time. What is the PDF for question number 6? Question number 6, the PDF will vary with time. The question 6, YTS is equal to 2, 2t and 3t square. 2, 2t, 3t square in three different value regions. Thus, A is equal to S1, A is equal to S2, A is equal to S3. Thus, PDF depends on time. So, this is not stationary. Implies not stationary. So, if it is not stationary at all. So first order stationary, second order stationary, white stationary, and stationary, all of them become redundant formulas. Implies D, none of the above. Because if it's not stationary, then it is not first order stationary, it is not second order stationary, it is not white sense stationary. So it is a very easy none of the above. So it is not stationary in any sense. The valid power spectrum density. Okay. So the only way to check for a power spectrum to be valid is that it should have positive values. For power spectral density to be valid, PSD should be greater than 0. PSD say HF should be greater than 0 for all F, or H omega should be greater than 0 for all omega. Now, in the first one, 6 by 6 plus 7 omega cube. First one is 6 by 6 plus omega 7 by omega cube. Here, if I put omega equal to say minus 10, so this will become h minus 10 will become 6 by 6 minus 7000. So this will be less than 0. So this is not a valid PSD. Done. First one is not a valid PSD. Second one, it has to be 4 e to the power minus 3 tau. Now exponential is always positive and omega is always positive too. But it is depending on time. So PSD cannot depend on time. PSD should only depend on frequency. So in the next one, so the A is ruled out. Option A is ruled out. It's not because it's negative. Option B is 4 e to the power minus 3 mod tau by 1 plus omega square. 4 e to the power minus 3 mod tau by 1 plus omega square. Now 1 plus omega square is always positive. Exponential is also always positive. So this is a positive number always, but this is dependent on time. Implies not PSD. PSD should purely depend on frequency, HF. Now C. C is 3 plus j omega square. Now you might say that 3 plus j omega square is of course positive. So what is the problem with 3 plus j omega square? Well, the problem is that this is complex. And what is PSD? PSD is nothing but, say, if there is a transfer function gf, it's just the mod gf square. So mod square cannot be complex, This thing, mod gf square, can never ever be complex. Thus, PSD is not complex. Therefore, this is complex, so not PSD. This one too gets crossed out. So we are left with D. So of course the correct answer will be D, but let's verify it for the sake of completeness. D is 18 delta omega. Sorry for the interruption. The option question number 7. Option D is 18 delta omega. Now, delta omega means it is 1 at 1 omega equal to 0. It is delta omega equal to 1 at omega equal to 0, 0 elsewhere. So this is first, it is positive. Second, since this is either 1 or 0, it is not complex. Third, it is not dependent on time. And fourth, if you integrate, it should give a finite power. So this integration 18 delta omega equal to 18 delta omega d omega, this should converge. We know that this is 18, so it converges. This is the total power. Total power. So we know that this signal converges. So therefore 18 delta omega converges. D omega converges. Since it satisfies all these properties, 18 delta omega is a valid PhD. Thus, the first one was ruled out because it was negative in certain places. The second PSD expression was ruled out because it was dependent on time, and the third expression was ruled out because it was complex, and PSD is modulus square of a signal, so it cannot be complex. So with this we conclude question 7. Now let's go to question 8. The autocorrelation function of an ergodic process yt is given by this thing. So the autocorrelation function of an ergodic process, you can look up what is ergodic process, but it is not very relevant in the scope of question 8. So we will be directly solving the power of the process. So what is the power? Question number 8, there is an autocorrelation given. So there is a Ry tau, which is 15 tau plus 4, 15 tau plus 4 by 6 plus 9 tau square plus tau to the power 4. Now, this is the Ry tau. Let's take the now the power. What is the power spectral density? Power spectral density is nothing but the Fourier transform of Ry tau. And what is power? Total power. It is integration of mod hf square is equal to, let's say this is is equal to PST. Now is equal to PST into d omega. Now to solve this, we know that total power P is this, but this is also Ry0. So the total power, you can find this theorem in books. The total power is the zeroth instant of the autocorrelation. So whatever is Ry0 is the total power. And how can we prove that? So we can solve from PST or we can directly get from Ry0. So how can we prove that? So what is Ry tau actually? Ry tau is yt plus tau dt in the whole time range, say minus infinity to infinity, whatever it is. So Ry0 is actually over the whole range yt into yt dt. So you are integrating the square of a signal over the whole range. This is what? This is the power, the square of the signal integrated. So this is the power. So Ry0 is the power. So what is the power here? The power is P equal to Ry0 is equal to 4 by 6. Rest all vanish. So 2 by 3. So this is option A. Now consider a random process. Consider a random process uh, xt equal to a sine 2 omega t plus b cos 2 omega t, where a and b are random variables. If xt is a White-Sense stationary process, then a and b are related as. So consider a random process. So xt is a random process where a and b are random variables. So if xt is a White-Sense stationary process, then what is a and b? Try to solve this question. If you are, if you want to solve this question, please pause here. If you are done solving this question, please fast forward 5 minutes. Please fast forward 5 minutes for the solution. Hello everyone, welcome back. So hello. There was a network disruption. So yeah, well the thing is, uh, xt is equal to a sine 2 omega t plus b cos 2 omega t, where a and b are random variables. So here xt is a Davidson stationary process. So on the average, the mean of the process should not change. So the mean should not change on average. Now here the hint is given that find the mean at 0 and at pi square by 4 omega. So let's do precisely that. Xt is a sine 2 omega t plus b cos 2 omega t. They have asked us to find e x square 0 and e x square pi by 4 omega. So let's find e x square 0 first, which is expectation of a sine 2 omega t into 0, so sine 0 plus b cos 0 whole square. So it is basically e b square. So the expectation of b square. Now, what is the expectation of x square pi by 4 omega? So why is pi by 4 omega used here? Pi by 4 omega is used simply to make the sine term 1 and the cos term 0 to get the a term. Because when you substitute pi by 4 omega here, you get pi by 2 in the argument. So cos pi by 2 is 0. This one will have whole square. So a sine pi by 2 is a into 1 plus b into 0 whole square. So it's basically expectation of a square. Now, the expectation of a WSS process is time invariant. So the process itself may not be time invariant, but the expectation is time invariant. That is the definition of a very weak sense stationary process. So E x square 0 is equal to E x square pi by 4 omega. So E implies E s square is equal to E v square. Sorry. Yeah, so E is equal to E S square is equal to ED square. So the correct answer is A. The correct answer is A. ES square is equal to ED square. Now let's go to question number 10. If yt is equal to axct, then ry tau is equal to what of rx tau? So this is a pretty straightforward question. Let me see the question again. Yt equal to axct, and so the yt is equal to axct, and they are asking us to they are asking us to find the relation between ry tau and rx tau. So what is ry tau? It's yt into yt plus tau d tau over the whole range of t. Now this is a x ct. Here a and c are constants. So a x ct plus c tau d tau. So a square will be common, x ct plus c tau d tau. Now what is this? To understand, sorry, not d tau. Sorry. This is dt. The integration is with respect to time. So let's substitute. Substitute ct is equal to p. So ry tau becomes a square p by c xp plus c tau, and c tau as, let's say, gamma. So p plus gamma. Now, and this dp will be dt by c dt. Sorry, not dt by dp will be c dt. So dt will be dp by c. So this will be a square by c, and ultimately this is between minus infinity and to infinity. So this is basically minus infinity and infinity. Let's write it in this way. So the division by c won't have any effect here. Xp plus gamma dp. So what is this? If you just overlook the variables, you will see this is exactly the autocorrelation function. Rx tau is equal to integration xt plus tau. So instead of t and tau, there is p and gamma dt. Sorry, this will not be d gamma, this will be dp. So instead of t and tau, there is p and gamma, but this is exactly same. So this will be a square by c x gamma. Sorry, rx gamma, not x gamma, rx gamma. And what is gamma? Gamma is c tau. So ultimately, ry tau is equal to a square by c r x c tau. Ry tau equal to a square by c rx c tau. A square by c. Okay. It will be a square Rx theta apparently. So I will go and check later. So you also do this question by yourself and you see whether you get a square Rx theta or a square by C Rx theta. I am getting a square by C Rx theta. So my answer is D, but here it is given as B. So I might be wrong, they might be wrong. So you please check, and if you find any discrepancy in the solution provided here, then you can raise a flag, you can raise a comment in the discussion forum and we will attend to it. Currently there is a discrepancy, so please check yourselves. Okay, with this we will be concluding today's lecture on random processes. Hope you have found anything valuable in this at all. And if so, then I'm very happy. And I hope to see you on the next lecture, week 9. For now, goodbye.